Hello and welcome lads and lasses to another video. My name is Tamil Chowdhury, aka Dr. Chowdhury, the only doctor without a PhD. Today this video is all about energy stores. Sit back and listen as we are jumping right into the video. Hello guys and welcome to another video. This video is all about physics, energy stores and systems. Let's start off with the video. Energy can be transferred mainly from one store to another. Now there's 8 stores to look out for. They are thermal, kinetic, gravitational potential, elastic, nuclear, electrostatic, magnetic and chemical. These are the main energy stores for energy. Now energy can be transferred from one store to another in 4 different ways. These are mechanically, basically by doing work, like throwing something, electrically with circuits and all that, heating, or radiation. Radiation meaning maybe sound or light. Now in physics you might hear the word system. Well, a system is basically a word to describe an object or a group of objects that you're interested in that is involved in energy changes. When energy is transferred from a system or in a system, we say the system changes. Now energy can be transferred between different stores in the system, between different objects in the system. It can also be transferred away or into the system. Now in physics we might get things called closed systems, and these are basically where energy cannot leave or enter it. So basically that means that the overall energy change is zero because energy can't leave or enter. Now let's take an example of energy being transferred by heating. Now, if we look at a kettle, for example, it's a 2-object system, the water and the kettle's heating element. Now, energy is transferred electrically to the kettle's heating element, and it transfers from the chemical to the thermal energy store of the kinetic heating element. Now, once the kettle's heating element receives the energy transfer, the thermal energy store increases. Now the thermal energy store is transferred from the kettle's heating element now to the water's thermal energy store, and that causes the water to heat up. And this is how, for example, a system can work with energy transfers. Now let's take an example of doing work. Doing work is essentially the same as saying energy transferred. Now if you take an example of a tennis ball that is like up in the sky, the gravitational potential energy will be depending on how high the object is. Let's say it's 100 meters high, it's going to have a lot of gravitational potential energy. Now when the tennis ball falls down, the energy is transferred from the from the gravitational potential energy to the kinetic energy of the ball, which causes this to fall down, increasing speed. Now obviously the speed does equal out in terminal velocity, but we won't get to that yet. Now when a tennis ball does fall down, in reality there's air resistance which causes the kinetic energy, no, not the kinetic energy, the energy transferred to not only be connected but to be wasted energy, so to the thermal energy store of the surroundings, because the friction causes it to partially heat up. Now let's look at some formulas. Alright, so the formula for kinetic energy is E equals half mv squared, where m is the mass of the object and v is the velocity or the speed. And yes, you do have to memorize these formulas. By the way, mass is in kilograms and speed is in meters per second. Now you might be wondering, why do objects that are on higher positions might have gravitational potential energy? It's because we're in a gravitational field, so if we lift up an object, we are basically doing work against the gravity, so we're transferring energy to the gravitational potential store of the object. Now the amount of energy that is stored in the gravitational potential energy depends on 3 things: the mass of the object, how strong the gravitational field strength is, and how high the object is that you're lifting it up to. And that can be simplified to an equation: E equals mgh, where m is the mass of the object in kilograms, g is the gravitational field strength in newtons per kilogram, and h is in meters. Now the gravitational field strength of Earth is mainly 9.8 newtons per kilogram. Now let's look at another formula for elastic potential energy. The formula is essentially E equals half ke squared, where k is the spring constant measured in newtons per meter, and E is the extension in meters. Now this formula can be applied is like when you have, like, let's say an elastic band, you stretch it and squeeze it, energy is transferred to the elastic potential energy. This formula does work because the extension is directly proportional to the force being applied to the spring or elastic, whatever you're testing, as long as the limit of proportionality is not exceeded. When the limit of proportionality is exceeded, if we look at it as a graph, it goes from a linear to a little curve. Let me just show it. Now essentially, when the limit of proportionality is reached, it's basically a straight line graph. Let me draw a straight one right here. Assume that's a straight line graph, and then when the limit of proportionality is reached and is exceeded, it starts to curve a little bit and doesn't become like a linear type of graph. Yeah, so it's not directly proportional essentially. And when that limit is exceeded, you can't really use that formula. Now that's the end of the video, guys. Really quick topic to discuss about, and obviously let's do a quick summary. Energy can be stored in 8 different ways: elastic, thermal, kinetic, chemical, magnetic, electrostatic, nuclear, and I'm missing one more, gravitational potential energy. They can be transferred in 4 ways: mechanically, heating, electrically, and radiation. A system is 2 objects or a group of objects, or 1 object that you're interested in energy transfer. Thank you guys for watching the video, and as always, see you next time.